Welcome to the deep dive. You're joining us today for, a pretty fascinating story about how things have changed in space, kind of under the radar. We're going to be looking at the connection between this DARPA mission back in 2007, Orbital Express, and something a lot of you are probably interested in, the X-37B, that super secret space plane the military's been flying for years.
Yeah.
We've been digging into a bunch of material for this deep dive, especially this book, From Thought to Flight,
Oh.
the X-37B Decoded.
Oh, great book.
Yeah,
Right.
by J.P. Ames. And it's interesting because he actually used some AI, like HAL, to help him write it. And then a guy a lot of people in this field know, Mr. Grok, he reviewed it, gave it his stamp of approval. What we want to do today is show you how a short mission, like just a blip on the radar for a lot of folks, actually laid the groundwork for this mysterious space plane that's still up there doing who knows what. It's all about how we're going to be working in space going forward, how we're going to be keeping things running up there.
It's a wild story, honestly. Orbital Express might seem like a footnote for a lot of people just glancing at the history of space stuff, but it really set the stage for what the X-37B is doing. Capabilities that are still coming to light, right?
Yeah.
It's a testament to the engineers back then, how far ahead they were thinking.
Yeah, like one breakthrough builds on another.
Totally.
So let's go back to 2007, right? Orbital Express. Short mission, but this book calls it a real turning point, like a watershed moment. They're saying it was the first fully autonomous satellite servicing and refueling in orbit ever.
Absolutely.
I mean, that's got to be a big deal, right?
Oh, absolutely massive. Before Orbital Express, if you wanted to service a satellite, it was pretty much send astronauts up like what they did with Hubble, those iconic repairs. Orbital Express, it flipped the script. It showed that really complicated stuff, docking, refueling, even swapping out parts, could all be done by robots. And they're doing it all by themselves.
That's wild.
The mission had two main players. Astro, the servicing satellite that Boeing built, and then you've got NextSat, the one getting the service. That was Ball Aerospace.
So they weren't messing around. They had some serious goals for this mission, didn't they? And according to the book, they knocked it out of the park.
They really did. 100% of the mission's objectives, they nailed it. It's amazing when you consider how complicated this all was. We're talking fully autonomous docking, not just bumping into each other. This is two spacecraft coming together perfectly, controlled from a distance and up close. They transferred over 14 kilograms of hydrazine fuel autonomously. And that's a huge amount when you think about how delicate spacecraft operations are.
Yeah, those margins for error are so tiny.
Exactly. And get this, they even swapped out orbital replacement units. They call them ORUs, basically modular parts, a battery, and a flight computer in this case, between the two satellites, all done autonomously. And they even did an autonomous fly-around visual inspection, one satellite doing a full check of the other, no humans involved. It's incredible.
So there's nobody on the ground, no joystick. This is all programmed in, happening on its own up there.
That's the revolution.
Right.
That was the whole point.
Yeah.
To do this, the engineers had to, they had to invent a whole bunch of new technologies, really push the envelope. The book highlights 4 of them as being absolutely essential. First, you've got the Advanced Video Guidance Sensor, AVGS, which NASA developed.
Okay, so let's break down that AVGS. What made it so advanced back then?
So what made the AVGS special was its ability to provide incredibly precise information for tracking and docking. And it did it in all 6 degrees of freedom. Imagine trying to dock 2 boats, right? But the water's super choppy. You don't just need to know how far apart they are. You need to know the angles, how they're moving forward, backward, up, down, sideways, their pitch, roll, and yaw.
That sounds pretty chaotic.
The AVGS used lasers to figure all that out with incredible accuracy. It would send out pulses of light, 2 different wavelengths, at these special reflectors they put on NextSat. By looking at the signals coming back, it could filter out things like sunlight and get a super clear picture of where NextSat was, whether they were miles apart or just inches away. It's worth noting there was an earlier version of the AVGS that had some issues on the DART mission, so they did a lot of software and processing upgrades for Orbital Express, and it worked perfectly.
Wow. So that's like the eyes of the whole operation. What about the hands, the part that actually does the work?
Right. So the second piece of tech that was crucial was the robotic manipulator arm, like a hand, and the Orbital Express Capture System. They called it OECS, which was more like the grip. The robotic arm was really sophisticated. A 6 degree of freedom system built by MDA, the same company that made the Canadarm for the Space Shuttle. It could reach out, grab NextSat, and move it around with super fine control. Once they had NextSat in the right spot, the OECS, made by SpaceDev, would lock the 2 spacecraft together. And this combo achieved something historic. The first ever fully autonomous capture of a free-flying satellite and the first ever autonomous hardware swap in orbit. It's mind-blowing, the coordination needed for that. It's like doing surgery with robot arms, hundreds of miles above Earth, and both patients are constantly moving.
Like a delicate ballet in space. So to be clear, the arm does the moving, the OECS does the locking.
Exactly. And then you need a way to transfer the fuel, right? That's where the fluid transfer system comes in, the FTS, developed by Vasico Industries.
That's the refueling piece, right? What were some of the big challenges they had to solve for that to work?
Refueling in space autonomously is a whole different ballgame. You're dealing with incredibly dangerous stuff like hydrazine in microgravity. On Earth, gravity helps keep liquids under control, but up there, fluids can do all sorts of crazy things. So the FTS had all sorts of safety features built in. Automatic valves for a leak-proof connection, interlocks to make sure the fuel doesn't accidentally get released, sensors monitoring pressure and flow rates, the whole 9 yards. It was the first time ever that propellant was transferred between 2 spacecraft in orbit, and it was all done autonomously. A huge step forward in keeping those space assets running longer.
Yeah. Sounds like a lot of things that could go wrong.
Absolutely.
But it all worked out. So we've got the eyes, the hands, the fuel line. What's the fourth piece?
That'd be the brains of the operation. You've got the autonomous guidance, navigation, and control software, the GNC, developed by Boeing. This was the AI system that ran the whole show. It planned, executed, and adjusted all of Astro's movements. It was taking in data from all the sensors on board, the AVGS, the star trackers, inertial measurement units, GPS, LiDAR, even optical cameras. Combining all that information, doing what's called sensor fusion, the GNC figured out exactly where Astro was, where NextSat was, and calculated the perfect path to get the job done. And here's a fun fact. Early on, there was a software glitch, put Astro into safe mode. But the system, working with the engineers back on Earth, managed to diagnose the problem and recover remotely. Shows you how resilient this autonomous approach can be.
Wow. So all this was happening back in 2007, robotically, autonomously. Okay, now let's connect this to the X-37B, the thing everyone wants to know about. The book points out that the X-37 program, it starts at NASA, then moves over to DARPA around the same time Orbital Express is in development. Is that just a coincidence or is something else going on?
The timing is really suspicious, to be honest.
Yeah.
The X-37 program, it kicked off at NASA in '99 as an idea for a reusable spaceplane. Then in 2004, DARPA takes over. This is right when Orbital Express is being developed, between 2002 and 2007. Knowing DARPA, they're all about high-risk, high-reward stuff, pushing the boundaries, and they were involved in both projects. So it's almost certain that what they learned with Orbital Express, especially about rendezvous, docking, manipulation, all that, it fed directly into the X-37B, how they designed it, what they wanted to be able to do. Orbital Express was like a proving ground, showing what was possible with autonomous stuff in space.
Like a stepping stone.
Exactly.
So for those who might not know, what exactly is the X-37B? How is it different from, or I guess, more advanced than what Orbital Express was doing?
Okay, so the X-37B, it's an unmanned spaceplane. Reusable, which is key.
Yeah.
And the U.S. Space Force runs it. It's basically up there for testing, experimentation, all kinds of classified stuff. It's famous for staying up there for a crazy long time. Some of its missions have lasted over 900 days.
That's years.
Years. Unlike Orbital Express, which is a one-time thing, the X-37B, they bring it back, land it on a runway like a regular plane, and send it up again.
So it's reusable.
Reusable. Huge advantage. It can fly multiple missions, cheaper in the long run, more flexible, and it's got this modular payload bay. They can change it up, put different experiments and tech in there for each mission. So compared to Orbital Express, the X-37B is, well, it's more of everything. Longer missions, it can operate on its own for years, it's reusable, and it's got this flexible payload bay.
So we've got this thing up there for years, and nobody knows what it's doing. I mean, the book talks about the secrecy, all the speculation. What do you think's going on up there?
Right. The secrecy is like part of its whole mystique. We don't have hard facts, obviously. It's all classified. But the book, it uses what's out there, open source intel, and it connects the dots logically. There's a few things that make a lot of sense, building on what Orbital Express did. First, there's the idea that they're testing even more advanced satellite servicing and refueling tech. Orbital Express showed it was possible, right? The X-37B, it can stay up there forever, move around. So people are thinking it's been practicing rendezvous with other stuff in orbit, maybe even trying out new robot arms, fluid transfer systems, all super secret. And remember, the X-37B has actually deployed and retrieved small satellites before, like Falconsat 8 on one mission. So that tells us it can definitely interact with other things up there. Now, Mr. Kroc, he's pretty clear in his review of the book. that we don't have proof that the X-37B is actually doing full-on satellite servicing, like refueling or repairs, in orbit. That's still classified, but when you look at the technology, the timeline, and what the X-37B is capable of, it makes a lot of sense.
It's like, okay, we might not have the video footage, but all signs point to yes.
Pretty much. And then you've got this really interesting thing that happened recently. The book talks about it, the OTV-7 mission. It wrapped up in March 2025, just a few months ago. And they did this thing called an aerobraking maneuver. Basically, they skimmed the X-37B through the upper atmosphere to change its orbit.
So they use the atmosphere to steer.
Exactly. Super efficient, saves fuel. That kind of maneuver is really important for future servicing missions, you know. You need to be able to move between different orbits, different altitudes to reach different satellites. You don't want to waste a bunch of fuel doing it.
So this is all starting to sound pretty serious, not just the technology, but what it means for, well, everything. Military strategy, commercial space, the whole picture. Let's talk about the military side first. What are the big advantages for them having this kind of autonomous space logistics capability?
The advantages are huge, honestly. First, you can keep your important satellites running longer, the ones doing reconnaissance, missile warning, communications, navigation, all that. You don't have to launch new ones all the time, which is expensive and a logistical nightmare. Plus, if something breaks, you can fix it in orbit, get it back online fast. And you can move your satellites around, put them where you need them, depending on what's happening down here. The book also mentions this whole area of proximity operations, which is kind of a touchy subject. Could be defensive, like checking out a suspicious satellite, or maybe even offensive, like, anti-satellite stuff, which is obviously concerning. But the main point is the U.S. Space Force, they're all about orbital sustainment now. It's a big part of their strategy. That tells you how important they think this is.
So it's not just keeping our own stuff running. It's about having an edge, doing things others can't, right?
Yeah, exactly. And then there's the commercial side, which is exploding right now. We've got all these companies popping up, doing satellite servicing for anyone who needs it. You've got Northrop Grumman with their mission extension vehicles, Astroscale doing debris removal and servicing, Orbit Fab, they're building refueling stations in space. All this is happening because of what Orbital Express proved and what the X-37B is probably refining even further behind closed doors. There's even a push to standardize the whole servicing process. Organizations like Converse are working on that. Imagine you could have a whole economy up there in orbit, build stuff in space, clean up the debris, move satellites around, like a whole logistics network, just like we have down here.
From fixing satellites to building stuff in space, the book even mentions in-space manufacturing and assembly. That's next level.
It's like science fiction, right? But it makes sense. Once you've got these robots that can move things, transfer fluids, make repairs, it's a natural next step. You start building bigger and more complex stuff in orbit. Eventually, maybe we don't even need to launch as much from Earth. We build it all up there, in space. Less expensive, less impact on the environment. The book talks about the dawn of space logistics, a whole new era where satellites aren't disposable anymore. They're like the infrastructure. They get repaired, upgraded, and the flow of goods and services in space, it becomes just as important as it is down here.
It's a whole different way of thinking about space. So as we wrap up this deep dive, what are the key takeaways about Orbital Express and the X-37B?
I think the big picture is this. Orbital Express, back in 2007, it was a game changer. It proved that all the key technologies for autonomous satellite servicing, they work. Rendezvous, docking, robotic manipulation, refueling, swapping parts, it all worked. And the X-37B, while we don't know all the details, it's basically taken that concept and run with it. Longer missions, reusable platform, probably testing even more advanced tech. It's paving the way for the future, both for the military and for commercial space, all thanks to those early pioneers on Orbital Express.
So for everyone listening, you should now have a really solid understanding of all this. The history, the tech, where things are headed. We've tried to make it easy to follow, give you the important stuff without getting bogged down in the weeds.
What I find amazing is how forward-thinking the Orbital Express mission was. Even though it was short, it had a massive impact, really set the stage for all the autonomous stuff happening in space today.
And that brings us to our final thought, something to ponder. We've got all this amazing tech being developed, robots doing their thing in space, but it raises some big questions. How do we manage all this? What are the rules, especially when these technologies can be used for good or for, well, maybe not so good? Servicing friendly satellites is one thing, but what about the potential for interference with other countries' stuff, commercial satellites, all that? It's a rapidly changing landscape, and it's something we all need to be thinking about. Thanks for joining us for this deep dive.